Hi, good morning, good afternoon, everyone, wherever part you are of the world. So, myself, Naveen from Digital Platform BU, and today we are going to discuss few things about FogFlow, some use cases, and let me share the agenda. So, this is the agenda for today. Learning goals. So, first we will go through the overview of FogFlow, about the key features of FogFlow and about the deployment architecture. Might be you guys have seen it earlier, but we have done few modification in last few years. So mostly on NGSILD based. So we have done few development in NGSILD. We have created few use cases. And on the basis of NGSILD, we have done some integration with other GEs. So mostly FIWARE GEs. So the use cases, basically use case about the how to create internal objects in FogFlow. I will tell you what is my main suggestion about that internal objects, how to create it basically in FogFlow. And then later on we will do the integration with NGSILD broker. I will give you in complete detail how do we send the packet through NGSILD broker, how we receive it, how that use case will work when we do integration with NGSILD broker. And the same thing with IoT agent, but conceptual, I will tell about the concepts, how we did integration with ultralight IoT agent. So basically we do some kind of analysis on the basis of the data we collect from our NGSILD broker. And we basically create some few useful commands on the data analysis, and we basically fire or execute those commands on other Gs. So everything, this is the learning goal for today meeting. So let me start the first part, the overview of FogFlow. So what is FogFlow? So FogFlow is basically a edge computing framework. What is exactly that? Which is basically initiated by NLE and NEC. So key features about the FogFlow, what is it? And I have framed it in few lines. So basically FogFlow is a standard-based processing pipeline over cloud and edges. So basically we can orchestrate FogFlow in cloud as well as in edge, or you can serverless computing as well. So basically standard, if you talk about the standards, so there are several standards in the market, but FogFlow basically follow the NGSI V1, in few cases NGSI V2 as well as NGSI LD. But basically we are focusing more on NGSI LD. So we did integration in past with WireCloud and Quantum Leap. Those are working NGSI V2. So that's why we get few support for NGSI V2 as well in past, I think in 2-3 years ago. But from that onward, we are working on NGSI LD basically. So basically it is an advanced edge computing model, which is basically data oriented. So everything, every model, every component is basically data oriented. You have seen that several softwares in market about the edge computing are basically topic based, but FogFlow is basically a context based or data oriented one. So basically it is intent based. So what is basically intent? If you talk about that intent, basically let me tell you about one example. Suppose if a child is lost in somewhere, so you can provide its photograph and the video, surveillance video. From that, you need to define in which area you are going to search that per child. So that area, the input you have provided, that will be intent. On the basis of that intent, FogFlow need to define the internal instances where it's going to instantiate it. So that thing is basically intent based. Means wherever how we are basically forking the task, that is based on the intent. So that is intent basically. So everything is context driven. So whatever data is coming from anywhere through the world from the producer, on the basis of that data, we orchestrate the things, we orchestrate the task only based on that content. So it is content driven FogFlow. So basically FogFlow is basically now is full member of FIWARE Generic Enabler. I think in last 5+ years we are doing the development and research in, and NLE and is mostly involved in this. So we basically create new features, develop develop new features and fix the bugs. So basically, it is used in smart cities and smart industries as well as smart agriculture. I will show you one example, or might be so. I will show you different example. So, sorry for that. So basically, it is attracting more and more people from other industry. So this is basically the roadmap, or you can say that what we have done so far. And it was started with Genetic computer-based software in the starting. Then 2016, it is necessarily complaint. And then 2017, it is incubated GE, serverless for computing. In 2018, it is basically intent-based orchestration added here. And we did the southbound support and GraphDB support in 2019. Southbound is basically when we execute some commands on IoT devices that flow. So that was it in 2019. Thereafter in 2020, basically we add authentication support, basically most in security and Kubernetes, and some few monitoring on the basis of Grafana, Elasticsearch, that is that in 2020, and we started supporting NSILD from 2000 onward. In 2021, we basically focus on integration with other GEs like Orion LD, IoT agents, and Scorpio. We did it. We also did with Quantum Leap and Cloud in past. But now we are focusing on NSILD, so that's why we focus it. So this is Orion LD. Sorry for that, it is only Orion is written here. So moving to my next slide, this is system deployment view. So I think you guys has already seen this system deployment view of FogFlow, but we have added GraphDB here. So GraphDB is new addition in Task Designer. So whatever the control object we create, or what do you mean by control object? So control objects in FogFlow is basically the service topology, for function, and you can say Docker images and etc. a few things. So we basically store those data into GraphDB, whatever the user create through Designer. So currently this is the current design. Might be in few months or in next month we are going to change it again. So we are doing some modification for efficiency and all. So might be this flow could change again. So currently the design is that Designer is basically we have two kind of nodes. One is cloud node, another is the edge node. In edge node, basically we run FogFlow run only IoT broker and worker. So worker is basically a kind of facility where you can execute your task. So what task? Task is basically on the basis of content. We orchestrate the FogFlow orchestrate the new flow. That flow is basically executed within that worker. The worker basically execute that. So in Cloud Node we have several services like Master, RabbitMQ, Worker, Discovery, ID Broker, and Designer. The broker in Cloud is same as the broker in Edge. They are same, but just in Cloud we have additional components like Designer. So Designer is basically a dashboard for FogFlow, where the user creates control objects, and Discovery is basically for availability purpose. And we are using RabbitMQ just for interaction between the master and the worker. Basically, master is basically have key responsibility of what you need to do in a fog function which you have created, how to send that data to worker, which worker will get executed, where that worker will be executed, everything, that knowledge, the execution plan that is created by the master topology. So basically till now topology master is working with interact with RabbitMQ, but in future design, which I think we will do in few, might be end of this quarter, so we are going to launch that Designer will basically talk with RabbitMQ for this internal object. So now Designer will send it directly to RabbitMQ. That flow Cloud and Discovery, that will be oscillated. So it will make the FogFlow very faster. So that for efficiency we are doing that. Other than that, we did GraphDB. GraphDB is storing basically the control objects. And other work is that when system goes down and systems come up, it gets restarted or sometimes shutdowns and any XMZ reason. When it comes up, so basically it loads the thing. Designer gets the things, the control objects from the graph DB. So it helps designer in that sense also. So that is basically data channel. This is control channel. You can see in red is control channel. The control objects are communicate using that channel, and this is black one is a data channel. So this is the system deployment view of FogFlow basically. So moving to my next slide. Basically how it works, how FogFlow works. So basically these three plans are here. You can see that left side, this topology creation and object creation. You can say service topology or fog function. Second is basically execution plan, how we execute things. Third is deployment plan. Now I will tell you in detail what we do in it. I will share you my dashboard after some time when I will show you, demonstrate the things. So I will tell you how you can create the service topology, how you can create the fog function. Fog function is basically a special use case of service topology when you have only one thing, one flow, one task there. Service topology is basically the combination of multiple combination of fog functions. The fog function connected in different ways, taking input from one another, giving output to other, which might be input for third fog function and all this and that. So that thing basically is done under service topology. Then in execution plan, as I told you, the master topology, it makes execution plan on the basis of intent. It makes sense where should I execute that my worker, what should be the execution plan, how many instances should I orchestrate. That thing is taken care in the execution plan. It do the automation, optimization, then it forward to deployment plan. Deployment plan is basically where we are going to deploy our instance, in which worker. So in FogFlow, basically, I will explain you, or I can prove you by the location on the basis of nearest broker. That instance will be executed there. The worker have its own limitation. Currently, the worker can instantiate up to 8 tasks from itself. From one worker, you can instantiate 8 tasks. So that deployment plans do. So basically, it just work on the deployment part where it will be deployed. So this is basically how IoT devices are connected with cloud and edge. So this is basically our FogFlow plan, how to execute and how to deploy. Now moving to my next slide. So this was the NGSILD support in FogFlow. I just told you that in a few years we are working on NGSILD support. So what is NGSILD? For a few people who don't know about NGSILD, might be every one of you know about NGSILD, but let me explain. So basically it is a simple information model, and it has its own APIs. Their grammar, how the API will be there, how data model will be there. It supports basically publishing, query, and subscribing. So if I'll talk about the FogFlow support limited NGSILD APIs. Why? Because that only is used in FogFlow. So as per the FogFlow uses, these APIs are used in FogFlow. You can use this. Basically, it facilitates the open exchange of data structures, information between the different stakeholders. These stakeholders can be from smart cities, from smart industry, can be from smart agriculture. So basically, when we talk about the FogFlow's NGSILD support in FogFlow, so basically we say that we provide the support of create API. See here, the create API is this one /entities, but in FogFlow you can also say that upsert API. So if we talk about the upsert API, it is important to FogFlow. Why? Because FogFlow orchestrates the serverless flows, serverless tasks. So at the time of execution or orchestration, the logic don't know whether it is an update, it is a create, or it is a partial update. So that's why we are using upsert. There is no need for taking care that or creating different logic. If this is update, I need to call this API. If this is update, I need to call that API. No need to take care of it. Execute this API, it will take care of itself. We support query API on the basis of entity ID, on the basis of attributes. We support delete API. The FogFlow support delete API, and on the basis of attribute or entity ID, then subscribe, subscription, update, and deletion of subscription. So more than that, what is more than in FogFlow? FogFlow basically add-ons. So there are 2 PPT for it. The add-ons, NGSLD add-ons. So integration of FogFlow with other NGSLD broker. So when I talk about the other NGSLD broker, it can be Scorpio or an LD or Stelio. Might be there are more brokers, but FogFlow did integration with only these one. I will give you example of Orion LD here today in demo, how we do integration, how FogFlow do integration with NGSLD broker. So basically, FogFlow do the data analytics, advanced data analytics on the basis of that data, so that one could generate some useful commands on the basis of that. FogFlow basically perform analytics on the captured raw data, as I told you, to generate some commands. That is all about. I already explained that Scorpio and Stelio, we did integration. And we did integration, FogFlow also did integration on the basis of NGSLD with agent. So how FogFlow do integration with IoT agent? IoT agent is integrated with FogFlow via an LD. So one device is connected with ultralight device is connected with IoT agent, then IoT agent is connected with Orion LD, and then Orion LD is connected with FogFlow. So in this manner, this is integrated. So we have done some few use cases, also created few use cases around it for smart agriculture. That's it. Moving to my next slide. Yes, this one. So basically, when we talk about NGSLD based application, so NGSLD based application. So in FogFlow, there is few templates which are already created for user use. If you want to create any use case, just use those templates. You need to write only few logic about it. Everything is already prepared there. I will also show you that those templates to you when I will explain about the demo. So few templates are JavaScript based, few are Python based, few are Go language based. Whatever the language you are comfortable with, you can easily create this one. So this is basically the master thing about it. So this is a function you need to define the received input in the context entity, and you need to define the publish output entities there. You need to write the logic behind it, the few logic. Everything is already prepared there. You need to do that. Then after, you need to create one image, token image of it, and use it in your for function use cases. I will tell you each and everything later on. I think someone has asked question. So I think 1.3.1. This is an NGSLD version we are supporting. Yes, it's not the latest one. Might be in future we'll do that. But currently we are basically focusing on visualization part. So we will upgrade it. It is the older version of NGSLD. We will upgrade it, FogFlow. So moving to my next slide. So now that use case and demo will start. So use case and demo, the use case is basically anomaly detection use case. So in FogFlow, basically we are already there are few use cases which are NGSI V1 based. Yes, Jason, you're correct. So mostly 1.3.1 is aligned with. So in FogFlow, you have seen several use cases already present there in FogFlow dashboard, but those are NGSI V1 based. What we are doing, we are just converting those use cases and catering more use cases on NGSLD. So we have converted few. So we are doing this work currently in current quarter also. So might be in future you will see that there is one more tab for NGSLD use cases that we are doing. So one use case is anomaly detection. What is basically it all about? So you can see that in a city, basically there are several stores, you can shops. In that shops, there are several devices or appliances are there which are consuming energy. So some of them, if use more power consumption, or it consume more power, or there is some fluctuation, so that use case will detect it. Yes, this is anomaly. Alarm is raised, it will be collected. So basically, we create two logic here, two operators basically. One is anomaly detector operator, one is the counter operator. I will tell you. Yes, Jason has said that you can see. Thank you, Jason, for sharing the link. Yes, so anomaly detector use cases, it have two operators, as told you. So basically, first one is segregate the each payload by its shop ID. So each shop have its own ID. It will generate that alarm on the basis of that ID. The operator will segregate, or you can say the function or the logic, it will segregate on the basis of the shop ID. And second one is the counter. The counter operator is running on a city level, and this anomaly detection is executing or on the basis of the shop ID, on the basis of each shop. So counter will collect how many alarms, anomaly alarms are raised within that city. So going to next, so this is basically the diagram, how this you can visualize. So this is a fridge, a refrigerator, this is a microwave. These are connected with two panels and one Raspberry Pi. You can also deploy FogFlow in Raspberry Pi. We have also built available for that. So it will go to dashboard and then cloud. So that's why this is basically the execution, how components or how these operators are connected. So this operator, anomaly detector operator, will give the output of this anomaly detector operator will go as an input to this counter operator. Someone has subscribed from the dashboard that counter operator. Someone is, you can define the rule here, anomaly detection, what kind of rule, that this is a threshold. Only 30 watt is my threshold. If the usage goes beyond it, you need to raise alarm. You can vary it. Well, it is 30 now, you can fix it to 60, then 80, 90, whatever you want. So this power panel is the input provider, or you can device from where we are getting that. And you please note it, the type is power panel for it. The type of payload is anomaly for it. So when we create the operator, we need to provide the type there. So this will group by city, this will group by shop ID. So we can, from the end, we can know that in a city how many alarms are raised, and from here we can know that which shop has raised that alarm. So this is the use case. Now this is basically how we create the use case, how one can create use case. So this is operator. First, you need to create one NGSID application. What is NGSID application? As I explained in the starting, you have templates. Using those templates, you can create the NGSID application. Let me show you. Okay, it might not be here. Might be an application. So not going to that deep, but I'm just showing you one thing over here. So operators, you can see the several operators, NGSID operator. You can see that alert for speed is here. These are the template basically. You can go in that. You can. There are several operators, already created operators. The code is here. These functions are there. You can define it. So like we have written in the functions, not going to that deep. We have written that normal speed is this, average speed is this one, like that. So you can define your own, write only few logic here. You can create that code for it. So using that, you can create the image, Docker image, and you can upload it to Docker Hub. Then that will go to Docker Hub. Then in that FogFlow dashboard, you can create operator. You can align that Docker image with that operator. And that operator can be used in any task. And then when the task will be executed by the service topology, so an execution plan and deployment plan. I've already explained that. What is the execution plan? So by this way, first create the application. First one, upload it to Docker. Third, create the operator from the dashboard. Then task. Then assign that task to any topology, and then create execution plan and deployment plan. So this is that simple. Now moving to the, so this is the prerequisite for the use case. Docker, Docker Compose, Git, Postman, you know, where you can get it. So this is the link for that. Now going to the FogFlow, this one. So in FogFlow system, we are having one edge node, one cloud node. So edge node I will execute over here. So I have the Docker Compose for it. Docker Compose -d. So this is sorry, I need to first invoke cloud. Okay. So this is cloud, Docker Compose, Docker Compose -d. Okay. Docker PS-a. Sorry. Docker PS-a. Yes. So these are the Docker containers for FogFlow. This is basically for Nginx. This is for FogFlow master. This is for designer component. This is for broker work. This is for worker. And this is for discovery. And this is for RabbitMQ. And this is for dgraph. So those are up as is here. Now we go to the dashboard. If I ping the IP, what was the IP? I forgot. 180.179. 180.179. If I'll click on it, so you can see that this is dashboards comes up of FogFlow. The FogFlow is now launched. This is this architecture. You can see different components are here. So if you click on discovery, you will see that one discovery is launched. If you see the broker, two brokers are launched. Why two brokers? One broker is from edge and one broker from cloud. You can see the IP 208.211. This 211 IP is for cloud and this one for edge. This is the master is launched, worker is launched. So there are a lot of options in FogFlow dashboard, but we are not going to cover each and every option. That is not our motive. Whatever will be related to our use case, we will follow that. So basically, this is the operator registry. You can register any operator from here. These are the already registered operators, which I told you that already there are few operators are there, which we have registered that are already registered. So this is the Docker image, which is there in the Docker Hub for our use cases. You can use it. You can register it. How you will create the operator? Very simple. Just click on that. You can click here, operator. This is the operator. Click on here. Gives the name some operator. Give some name to this operator. And you need to provide some description over here. I will let you know later how you can create it. So this is a service topology. I told you there are few service topology already registered. You can see this. So if I'll see about topology LD on this one view. So this is already created topology. You can see that this is what is, I will explain you what is it. So this is a task. This is entity string. And you can see here. This is entity stream. Entity stream means whatever payload will come to FogFlow system, that entity stream will listen it if the type comes to this one. So this type payload, if it comes to FogFlow, it will capture it. On the basis of what it will segregate? It will segregate on the basis of entity ID. It will give that to this task. What is this task all about? This task will check basically detector. This task name is basically detector. This is the operator name. What operator is this task is aligned with? This is the output of it type. This shuffler, what shuffler will do? It will shuffle all the things coming from left and what are coming, or you can say two or more tasks can be shuffled by this shuffler. So what is this task all about? This is the counter task. I told you this is the counter task which is executing on the city level, and this is basically the anomaly detector task, which is on the basis of shop ID it is detecting. So these are already created service topologies. If you want to use these are the basically use cases. All are from NGSI v11. This is also this one next gen anomaly detection. This is basically NGSI LD based use case which we have recently created. Currently, this in future you will see that there is one more tab here. That tab will show you all the NGSI LD1 use cases that is in our plan. So this way you can see this is service intent. You can add that intent here. I will let you know how you write. So now let me start with, now we know that how we can create an operator, how to register service topology, what is their end system status, okay, and what is that. So let me start with this use case. So this is the next gen anomaly detection use case. Let me execute. So this is the diagram of this use case. I have already explained it. This is the management portal. This will show you how many workers are connected. So currently 2 workers are connected. If I click on here, this is a worker 2. This is the worker 1. This is the task. How many tasks? You can see there is no task running it. Why? Because till now we didn't send any intent, so there is no task. As soon as we will send the intent, task will get executed over. So this is the result. This will show the result when this use case will get executed at that time. So let me execute this use case then. Next gen service topology management. If I click on the start, we just executed the intent. You will see here. Let me start it. Okay, so let me fire one payload first. So this is the payload. What is this payload? So this is the payload for the entity which we are going to create. If it's not visible, then I'm zooming it. Might be it is visible now clearly. So this is our cloud node where we are executing. It's working on this port. This is content aggregation, and this is the payload basically. So this is all about the shop ID and all icon. Let me copy it. So this is not interactive because I have not applied IX here. Then you can, if I apply IX here, then you can easily know that output will 2.1 will arrive. So if I'll go there, we will check on the task. So task is launched. Why this task is launched? Because we send this data. As this data will arrive, this task will get executed. And this task you can see here. And now you can see that the data in this task is 20, right? And you can see that what is it? This one, rule. So in rule you can see that current threshold is 30. If it goes beyond 30, then it will show you that alarm. But currently there is no alarm. Task is launched. The task was listening. As soon as we create that topology, service topology for that, let me show you a topology. This one. As soon as this topology is launched, it has started listening. I showed you that this is listening for this type of data, power panel data. This is power panel data type. So it was listening it. As soon as it arrived, it invoked the task. So the second stream was listening for rule. Rule. What was rule? This is what was the rule? Rule is there, which I just showed you. Sorry, this rule. So current threshold is 30. If I send a data beyond 30, suppose 40. So you will see one alarm in the dashboard. Currently there is no alarm, right? I've just shown you there. Imagine in result there is no alarm. If I just send it in management, there is nothing. In result there is nothing. Task is launched. Okay, and let me check what happened. What's happening? You can see this registration container is invoked, and okay, might be threshold. I just what I sent. Might be. Let me show you a log of this Docker. Logs. So update threshold was 30. Currently 30 was the threshold for that. Might be I've pasted again. Sorry. Let me try this packet again. The threshold is 40. All Docker are launched. Just launched. Task is here. Let me check. Task is launched. No check task there. So no reason. We have launched the app. Intent result there. Result is there. I don't know some logs why it is happening like that. Only 30 input is receiving 30 input. We are sending 40, but it is not. Let me. Let me stop it. Let me check it again. Topology master. Management. It's already started. Let me run it again. Compose. Let me me certain reason why it is not working. Docker compose -d, launching the cloud, then Docker compose -d, Docker ps-a, all things working fine, master Docker, okay. Docker ps-a, working fine, okay. I don't know reason why this. Okay, we'll check it later. Might be moving to my next slide then. In that case, so I will get back to it again after few time. So this is the integration with NSLD broker. What we have done in NSLD broker. So this is the RNLD. How this integration is done. So this is the provisioning part. Step 1 to 3 is provisioning. So this is how this is connected. I'll explain you. NSLD broker is connected with FogFlow, and FogFlow just first do some configurations, or you can provisioning kind of thing. FogFlow subscribe NSLD broker for the input. When that entity is created in NSLD broker, it sends update to the FogFlow. Then FogFlow do kind of analysis on that data arrived in step number 4. We have written some fog function for it. When it get executed, so it will create one command on the basis of that, and it will send back to the NSLD broker. But before that, NSLD broker need to do subscription in FogFlow broker, and when that subscription arrives here in FogFlow, it checks the data. If data is there for the particular subscription, FogFlow return back the data to NSLD broker. You can check from your commands that whether this data is arrived in NSLD broker or not. So these are in this step 1 to 3 belongs to provisioning, step 4 for function creation or logic creation, step 5 and 7 returning that or creating that command to sending back that command to NSLD broker. So we can check it how it will work. So this is the edge, this is cloud. Let me run the RNLD. Docker compose -d. Yes, so this is RNLD. Worker is RNLD is up. Few steps for it. So this is the curl command for checking whether RNLD is up or not. I'll fire this command over here. So RNLD is up and running with this version. So now RNLD is up, FogFlow is up. Now we do need to configuration on an RNLD. What kind of configuration? That subscription command. So let me run that command. So this will issue a subscription. So let me explain about this payload first. So this is the type subscription, entity type vehicle. From the base for all the vehicle type entities, we are doing subscription. The FogFlow is doing subscription. For in notification, it is giving the endpoint of this FogFlow where it need to reply, and this is the application for that data set. So the subscription is done, accepted. Now second step, subscription is done. Now, if we need to send some update in the Untitled broker for which subscription reason. So this is a payload, necessarily payload. The type is vehicle, brand name is basically Mercedes-Benz. This is for a vehicle. So, okay, I will tell you what we are doing in this use case. So basically what we are doing in this use case, this is the speed of the car. So on the basis of speed of a car, the data will arrive, the car data, the car moving data will come from NSLD broker to FogFlow. Suppose it gets some data, it will send it to FogFlow. FogFlow have one smart function here. What that function will do, it will check the speed of that payload. It will do analysis. On the basis of that, whatever is configured or what is the business logic there. On the basis of that, it will create one command. That command will arrive into NSLD broker. That command will tell you whether the speed is under risk or that speed is normal. So any police station or policeman or any traffic checking personnel, they will subscribe for that. So easily they will know that something is wrong. This car is moving so fast. We need to do some kind of action against that. So this is the use case. So till now, what we did subscription. This is the entity payload about that car. So currently you can check the speed is 30. Speed is 20. Okay, so it is normal speed. So send this data. This is arrived in NSLD broker. Now, what was the fourth step? We need to create one serverless function in FogFlow. So we need to do that. So going back to the designer page of FogFlow. What was the IP? I forgot that IP. 180.179. 180.179.211 is the IP. We need to register an operator over here. So I will tell you how we register operator. So operator, we need to register this operator. We need to create one operator. This is operator. You can name this operator anything. So suppose I create a name. To what to page, or you can say operator speed check. This is a speed check operator. Again, this is a speed check operator. We apply it here. We need to submit it. So what is operator? Basically, the operator is just a body. Okay, just a skeleton. What Docker image will do? Docker image is the soul. We are sending that soul into that body. So you need to overspeed. This is a image, or you can say intelligence, or whatever the inside application we have created. So this is a Docker image for that inside the operator. So you can check which hardware type you have. We are using x86. The Linux is OS. Operator is counter, or you can send that. Docker image operator, we just created operator speed check. Okay, so we just created that operator. Now we are aligning this image or this Docker image with this operator. Now register. You can check in operator. This operator speed check is created. Okay, currently this is created. Now what we need to do? We need to create one fog function for it. Fog function is basically a serverless function. How to create it? Fog function, we need to register one fog function. Name of the fog function, suppose fog function, anything you can write, or fog anything. Underscore speed check. This is a speed check fog function. We need to create it. First, we need to create one task. In the task, we need to provide name the task. You can write any XYZ. Task for speed Operator, you need to define which I have created. Operator speed check. So first we create the operator, then we create the task. So operator speed check I've already created. We need to apply it. Applied. Then we need to submit it. Sorry, we need to create one entity for it also, entity stream for it, on which this task will listen. So we need to tell which type of entity is there. So let me check what was the. So this is the type. So we are creating this entity over here. Type is vehicle. We want to know all attribute changes on the basis of all attributes. So all good by entity ID. We will submit it. Then you need to connect with this operator. Okay, these are connected. So we have created one for function very easily. First operator creation, then basically image need to be added with that operator. Then that operator need to be added in this for function. So submit. This is submitted. So this for function is created. For function speed check is created. Okay. Now, if that is created, now we will go to the page. Okay. This for function is created. Step 4 is done. For function is created. Because we have already sent the data from here, this for function will know that what data is arrived from or an LD broker of type vehicle. Now it will do some execution. It will send back the data to the NLD. So what you need to do now? Let me go there. So step 5 is basically we need to carry the data which is arrived there on an LD. So this is the GET request, which is getting the data on the basis of type vehicle. Okay, so in this LD commands on the basis of vehicle, it is doing it. Let me go there. If it's not visual, let me zoom it. Insert. Okay, I forgot one. Sorry, I just pasted wrong command. This was not there. Sorry. I don't know, this VM is not answering. Why not? Logs. Docker entry point, Docker master entry point. Okay. The task is not launched. Why? Let me switch on some another VM then. So also some VM, might be some VM issue that Docker is not on, but this is the concept basically. Conceptually, we collect data in that manner. So this is we need to just collect because we have now we know how to create basically the for function, how to create instance, how this instance gets launched, and how to create that operator and how to link that image into that operator. So we did integration with this IT agent broker as well. IT agent, sorry. So IT agent's concept is overall same. We have Orion broker. FogFlow is connected with that broker, or it is connected on the basis of the same steps which I just told you for earlier PPT. How all steps are there. Some few additional steps are there. IoT agent is here. IoT agent is connected with Orion broker. We did some provisioning here. From step 1 to 4, the provisioning is done here. From step 5 to 7, 8, and 9, 11, it is already there, which I have explained in this early broker. This one integration. So this is IoT device. IoT device for what? For ultralight devices, IoT devices. This is HTTP devices. Online, you can check these devices. That device is connected with the IoT agent, and IoT agent is connected with the Orion broker, and Orion broker is connected with FogFlow. So in this manner, basically, we integrate the IoT agent. I have one diagram for you. So let me check about the system. 143. So Orion LD is there, Docker, Ansible is there, everything is proper. This is cloud one. We need to this was the 1 minute. 1, 4, 3. We are sending this data or NLD data to there. This is sorry. So Orion LD, we created one entity here. FogFlow has already subscribed this Orion LD entity, so we created one entity here in Orion LD. Now we need to check whether this, on the basis of this entity, the FogFlow. Oh, sorry, I have just switched the machines. I didn't create the for function. So we need to create one for function here. This one for function. Anything for function. Speed. Latest. Our speed. And then task operator image operator speed check. Apply. We need to create on a string. Vehicle. We need to connect it. We need to submit it. This function is created. This one. We'll check the task is launched for latest. This was our earlier task. We linked with another VM. Somehow that VM is not responding, so we just switched another VM. So in another VM, this task is created. Let me check. Now, because speed was 20. Docker ps-a. So let us run Docker discovery, worker latest. So this one is the task which we have created now. Let's send this payload again with speed. Speed is increased. Speed is increased with 60 suppose. So it is beyond the limit. We are sending speed to 60. So let's see if we'll get some notification. Yes, it arrived. Let's check what notification we got. Sorry, IP is again wrong. 143. We just switched to another VM because that was not working. So this is the data which we got in response. So data is basically this is the same ID, the same Mercedes-Benz credited, and just an LD one. This for this context, so we got this one. Okay. So we got this one as earlier it was we were not expecting this thing. I don't know about the VM, that VMs were not working fine. So now this data is arrived. So it's working fine. So that's how we find that. Okay. So this was first step number 4, because step number 4 was there. It do some data analysis on the basis of that, then in return send back to the data to the NSID broker. So now what we are doing, we will do one subscription on the basis of NSID. We'll do subscription in FogFlow. So this will do subscription in FogFlow. I've just changed the VM. Let me write the IP of VM 143. So this is subscription, or an LD is doing subscription. On this endpoint, notification will be to an LD. Let's do that subscription here. Yes, subscription has happened successfully. This is subscription ID we got. And let's check what data is out there. So yes, sorry again, I forgot to change the IP. This is get request on the basis of V1, sorry, on the basis of this D result have provided for basically the output which will be created by this broker. Let me show you that. So DA result is a type of this upsert. So let me explain this. I just forgot to explain it. So this is upsert API. So how FogFlow will notify to inside the LD broker or N broker. So it will send one upsert API to this NSLD broker or an LD broker. So this upsert API will create one API, one entity in NSLD broker, or it can basically update that. Okay, so that's thing we want to do that. So if we'll do curl command over here, we got response 200. Okay, Let me show the task logs. Logs. This one. So in task log, the task which we have launched is basically is under risk. Because why it is under risk? Because we provide the data 60 here in the payload. So up to 50 it was under common, 30 it is normal speed, and beyond that it is this one. Yes, we send the value 60, so that's why it is under risk. So that's in this manner we'll get the. So this is a use case of overspeed vehicle, which we know that in the Docker log we found that speed is under risk. Okay, so that was all about it. Let me check. Let me do then enemy detection use case, next generation detection. I think I got some message. So started this task for enemy detection. Now you will see the task is launched for it. Okay, so now send the payload for it. What was the payload? Is this one? IP is 143, or we just switched the VM. Somehow it is not responding. So this is for enemy detection use case. So speed enemy detection threshold was 30. Now we send it 40. Okay. So you can see in result section. Sorry, this is sorry. See. The session is launched here. Yes. Sending it again. 43. You can see one enemy is directed here because the wattage is 40. Earlier it was in the rule. You can see that it was 30. So we got one enemy detection. If we set it, or if we send below 30, suppose 20, the wattage is 20. If we send it, so there will be no alarm. There is only one alarm till so far. If we send it, you can see there is no alarm. If I can send it about 40, you can say if it's 50. The management portal. So in this management portal, basically we get the alarms, how many alarms are raised there. This tells the timing, how many timings are, what is the time there, 1440 is here. Task shows that how many tasks you have launched, in which worker it is launched. This shows the task. And this is a management, basically, topology. That's all. Sorry for that. So this VM211 is not responding. That's why I've launched this 143. So that has become a little bit messy. But in this manner, we can do integration with necessarily broken. In this use case, we launched how this task was launched, how we create operator, and how task was executed, and how this we create service topology. For a few test use cases, the service topology is already there. Execution plan is internally. Deployment plan is basically where this task was launched. So in worker, you can see easily how this task was launched. So this was all about it. I just told you concept. We are not going to demonstrate it. IoT and integration. Concept release both are same. Oh, thank you very much. Thanks. Over to you, Jason. So one more thing. This is if you have any query, you can raise any issue on GitHub. Or this is the base directory of, or you can send me a mail for it. Let me see chat if someone